if you have a level surface and we have an object on top, face on top, and then we're like, okay, we need to move the object. Come. So let's try to move the object. Trying to move the object. It's not moving. Hello, please move. Thank you. Okay, so let's say, right, we apply a force on the object. Okay, if we've discussed this before, if we put the term smooth means what? No friction. No friction. Yep, no friction. Friction is negligible. Okay, yes, friction is negligible. No friction, zero friction, correct. But if the question doesn't tell you that it's smooth, you never ever assume that there is no friction. You never assume that it's smooth. The question must tell you it's smooth, then only you can say that there is no friction or zero friction or the friction is negligible. If it doesn't tell you, you have to assume that it is possible that there is friction. Okay, now all of you have learned friction before. You need to be aware that friction is a force that doesn't exist on its own. If we place an object on a surface and we do not move the object, leave it like that, is there any friction? No, correct. So friction exists only when you exert a force. Friction is one of the many many things that can appear due to Newton's, like not due to, let me rephrase. I haven't discussed this one yet. Newton's law of motion says for every action there is an equal and opposite reaction. I haven't discussed this yet. Have you learned this law before? Have you seen this law before? Yep. You learned before? Do you know what this means? ... So you've seen this before. Was it something you learned officially or just something that you read, like because you love physics so much, you sleep with textbooks under your head? I don't know. Why like that? So you learned this law before in So you learned this law before in class lah. Why so much now why so much blank one? Wait, funny. So you learned this in an official capacity lah, in academic sense, in an academic capacity. Why isn't the text appearing? All right, I thought my check got robbed. Okay, so you've learned that friction is also one of the forces that can be explained through Newton's law of motion. Yes, okay, then I don't have to explain. Good. So if let's say we exert a force, we pull a force this way, right? We know then from Newton's, actually not because of, Newton's law explains it. It is not because of Newton's third law. Newton's third law explains it. So anyway, when you pull a force, because of the force exerted on the object, this generates a frictional force between the surfaces as the object moves. So that's friction, which I label as Fr. So Fr is friction. You've also learned that in order for the object to be able to move, the force must overcome friction, correct? Okay, so when you pull with a force of 1 Newton, let's say, the friction will automatically become 1 Newton. Because again, this is not because of Newton's law. Newton's law explains it. You already learned that because it's a generated force, whatever the value you pull the force with, the friction has a certain value. It will match that value. If you increase the force to 2 Newton, the friction will automatically increase to become 2 Newton. If you increase the force to 5 Newton, the friction will automatically increase to become 5 Newton. Correct? You've learned this before, right? So what happens is, as long as you keep keep putting a certain amount of force, the friction will always increase and matches that value of force. But there is a certain maximum friction which the surface has. So if you increase the force beyond that maximum, what was question value? 5 Newton. 5. Okay, that means let's say, for example, this surface has a maximum friction of 5 Newton. So if you try to increase more than 5, let's say you increase to 6 Newton, the friction will try to match to 5. It cannot. Hey, what am I saying? Sorry, backspace, 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 backspace. If you increase the force to 6 Newton, the friction will try to increase to 6, but cannot because its maximum is 5. So you pull 6, it can only go up to 5 because that's the maximum. So when the force is more than the friction, then the object can start to move, right? But when we say more than 5, it doesn't always mean it must be 6, because more than 5 also can be how much? Can also be 5.1, can be 5.01, can be 5.001, can be 5.00000000000000000000000000001 also can. Because I tried to be like your chat. Okay, but you get it, right? it it doesn't always have to be a round number, because in real life, like the numbers is something that is a human construct. Numbers are a human construct. In real life, as long as this is more than this, you know something will move already, right? So what you learn here is this: if let's say, right, the question tells you that the object is moving with constant velocity. Constant velocity means zero acceleration. So I don't want you to say no acceleration. I want you to say zero acceleration. Same thing actually, right? By right, when we say smooth, it should be zero friction or negligible friction. We try not to use the word no. It's not wrong, but it's not 100% accurate. So I want you guys to learn to be like full accurate, like Chihuahua. Okay. So constant velocity means zero acceleration. Now this is important because in this formula, F equals ma. F equals ma. Let's focus on A first. Now, if we write here that A equals to 0, A equals to 0, there are two states of motion. Zero acceleration, one of it is that the object could be moving with constant velocity. What's the other state of motion where acceleration is 0? Do you know? Okay, so you have forgotten everything you've learned in 2.1. When it's stationary, constant acceleration. Yeah, when it's stationary. Constant acceleration is not 0. Constant acceleration means there's number. Like A equals 1, A equals 2, that's constant acceleration. Okay, so when A equals 0, there are two possible states of motion: when it's not moving or when it's moving with constant velocity. Okay, so like earlier, if we pull with 1 Newton force and friction becomes 1 Newton, not moving, right? So when it's not moving, A is 0. So how does this translate then? So based on Newton's second law of motion, they come from, ooh, okay, they found what they observed, and then they discovered this city. Okay, so this is what we found, that when the acceleration is 0, and this is mathematical, so you think about it logically, if A equals 0, we know mass is 0 times 0 is 0, right? That means whatever the value of mass is, mass could be 1 kg, 2 kg, 1,000 kg, 3 million kg, doesn't matter. Whatever times 0, F will be 0. Okay, F will be 0. But in this case, you look, But how can that's this? It's not that F is 0. F is 1 Newton, ma. What are you talking about? So you got to remember that F in this case refers to resultant force. Okay, resultant force. So if you recall what we learned about resultant force, it's like you plus, minus, you count, you find out what is the final result of the forces acting on this object. So if you see this diagram, you've got 1 Newton force to the right, friction going to the left, both force is equal, correct? Can you see that in this situation, the net force is 0? It's not to say no force, got forces acting on it. But you plus and minus everything, the result is 0. So because the result is 0, that's why it's not moving, or that's why the acceleration is 0 in this case. Okay, yeah? So in this case, this one is stationary, let's say. So let me remove the constant velocity, otherwise you get confused. Like, how come got two things? Let's say it's not moving, it's stationary. Okay. So if the maximum friction was 5 Newton, teacher, how does, no, level surface is not smooth surface. Level surface just means horizontal. Teacher, can you repeat how you know 5 Newton is our maximum friction? That one, a question must tell you. You won't know. The question must tell you. Okay, yeah. I realize I used up the whole Jamboard. So what I'm going to do now is I'm going to duplicate it. We're going to go to slide number 3 now, okay? Slide number 3. So if you're on the Jamboard, on slide number 3. Yes, the question will have this question didn't tell you. I'm going to show you how you're going to find out. I need to show you how you can find out. The question normally don't tell you. The question will give you a hint. It will hint to you what's the maximum friction. So we don't know what's the maximum friction. Okay. I'm aware that I could have just drawn this, but you know what? It's okay. I could have just drawn this instead of duplicating and rubbing off, but never mind. So this particular question tells us that when we pull a 5 Newton force, question 3, talking about question 3, it's moving with constant velocity. So from here, we know that, constant velocity means what? You are expected to know constant velocity means acceleration is 0. And if you remember, when acceleration is 0, if acceleration is 0, therefore the net force is 0, correct? Net force is 0. So if the net force is 0, you look at this, or resultant force. Net force or resultant force. I sometimes use the term interchangeably. So if the resultant force is 0, you look at the diagram, but then it's not 0, there's one force pulling, there's one 5 Newton force. So when you see a 5 Newton force, this means that a frictional force is being generated in the opposite direction, which is equal to 5 Newton. This information is not given, but it's implied. You need to know how to figure this out on your own. That means this right here, implied information. You are supposed to figure this out. How you figure it out? Because of this information. They told, I wanted to use the brush. They told you this constant velocity is moving constant velocity, So that's your train of thought. Because they told you constant velocity because they told you object moving constant velocity, this tell you a equals 0. From here, you know a equals 0, therefore f equals 0, and that's how you came up with the value of the friction. Okay. How come, then how do we know that this is the maximum friction? Never say also. You study 5 Newton, then how you know that it's maximum friction? Because it's moving. If the force does not overcome friction, the object will not move. The fact that this object is now moving, this means that the force has just overcome friction. Just overcome friction. That's why it's moving with constant velocity. So this means the implied information here is that the force has just overcome friction. because it's just overcome friction, we assume at this point, the friction is equal to the force applied. Why? Because you want to get F equals 0. So that means in order to get 0, the friction must be the same as the applied force. Does that make sense? Yes? Okay. So this now tells us if the force has just overcome friction, that means we now know the maximum friction is 5 Newton. No matter how much you increase the force now, the friction cannot increase because already that's the maximum 5 Newton. So the question then tells us we increase the force to 25 Newton, correct? So you look at question 3, look at your workbook. I'm trying to draw level. I know it's not straight, you imagine it's straight, okay? Because I cannot, you know lah, my drawing. The reason I studied engineering was because engineering, right, we use ruler to draw everything, right? We now increase to 25 Newton, okay? Same object, same surface, but now we pull with a force of 25 Newton. You try to pull, remember the friction will try to match, cannot match. The maximum friction is 5 Newton. That means the friction that's still acting here is still 5 Newton. The friction is still 5 Newton, okay? So remember that if you want to solve this question, you need to use the formula F equals ma. In this case now, net force is not 0, and it's not moving constant velocity. It's just asking for the acceleration. So to count the net force, you see that 25 is in one direction, find it in the opposite direction. So based on this, how much is the resultant force? Or how much is the net force? 20 Newton, correct? So I'll just write here, so to make it clear, okay, so that means the resultant force. I know some of you know, but I'm just writing it out step by step, so that at least those of you who can't follow, you can understand why. 20 Newton. That's why when we substitute, it becomes 20 equals, so the mass is 5 kilogram. I'll just put here 5 kilogram, okay? So 5A, from here you can count, that's how you get this answer, okay? So the focus of this, what I'm explaining in this question is, okay. So what I need you to keep in mind when you come across this kind of question is this implied information. Okay, now I realize I used the brush, you cannot see my star. So I will change to this so that you can see the star. Yeah, this is the information. So when you come across a question like this, when they tell you, oh, I'll just move to constant velocity, the moment you see constant velocity, the purpose of this is to tell you this. Once you get very familiar, right, with the thought process, straight away you can get the maximum friction. But for now, whatever I explain step by step is to explain to you why you can get, how we get the maximum friction. Okay? Okay? Okay?